Hi everybody, so this video is all about solving differential equations. So remember we talked in class today about what a differential equation is, but just as a quick reminder, solving differential equations really just means we're trying to find the original equation when I give you the derivative. So we're trying to find y when we're given dy dx. That's really all it means to solve a differential equation, okay? So a differential equation is an equation where we know the derivative of a function. We can use antiderivatives to help us solve differential equations. That's why I said this is so important that last chapter is so important for what we're doing right now. When a problem asks you to solve a differential equation, it means that you need to figure out the original function based on the derivative. So for example, if we have dy dx equals 3x squared, then we know we can just take the antiderivative, and that's just a nice simple undoing the power rule, and we would have x cubed plus c. All right, so this answer right here, y equals x cubed plus c, this is what we would actually call the general solution. All right, because we don't know what that c value is, this is just general. Once we find c, we call it a particular solution. We'll talk about that in a second. But if we don't know what the c value is and we're just left with y equals x cubed plus c, that's the general solution of a differential equation. Okay? So figuring out c we talked a little bit about in class today. So if we have an initial value, so in other words, if we have an ordered pair that we know from the original function, we can calculate the c value. When we have that particular value and we use it to calculate c, we call this finding the particular solution. So if we find the c value and plug it in, that's the particular solution. Anytime it's got the c in it still, that's the general solution. So here's this same differential equation. So we know that y is equal to, x cubed plus c. And now what we're going to do is we're going to take the x and the y that we were given. So we were given the point 214, which is an x and a y, and we're going to substitute it in. So 14 is going to equal 2 cubed plus c, and we end up getting that 6 is equal to c. We know 2 cubed is 8, and we can subtract it over, which means our particular solution is y equals x cubed plus 6. All right, so let's go ahead and write the steps really quick before we dive into some examples. So the first step is to separate the variables. Now on the example that we did up here, we didn't have to do that. I did one in class where we did. But all this means, really separate the variables, means that you must have been given a dy dx that is defined in terms of x and y. And so we have to separate the x dx on one side and the y dy on one side so that we can actually continue on with the process. All right, so then we use an integral to find the antiderivative on both sides of the equation. We're going to write the plus c on only one side, and then we're going to solve for c if that's possible. So if we're given that initial value so that we can get the particular solution, we're going to do that. And then the very last thing is that we will solve for y. All right, so let's see what this actually looks like then. So let's see, solve the following differential equations. Find the particular solution that passes through the given initial value when possible. So that's going to be important. Sometimes we can find the particular solution and sometimes we have to find the general solution. So if you look at number 1 here, you should notice that we're not given an initial value, which means we're not going to be able to find the particular solution. We're only going to be able to find the general solution. So let's take a look here. We've got dy over dx equals secant squared x plus 2x plus 5. Well, if I tried to put my integral symbols in right now, there's no dx over on this side, and there really needs to be because this is where my x's are. So I'm going to multiply both sides by dx, and I end up with dy equals secant squared x plus 2x plus 5, and then times dx. All right, and so now I can actually take the integral on both sides. And we know that the antiderivative of dy, remember there's just a 1 in front of that, which means we're just undoing a power rule, and we get y. The antiderivative of secant squared x is just tangent x. The antiderivative of 2x would be x squared. Then we have the antiderivative of 5 would be 5x. And then we need to remember to do our plus c at the end. On this one, there's no initial value to plug in, so we're done with that one. All right, let's take a look at number 2. So we'll notice again we've got dy over dx, so we need to get the dx over to the other side to be by the x's. So dy is going to equal e to the x minus 6x squared dx. So we separated our variables. There's no y's to move over to the other side, but we did have to move the dx over to the right to be by the x's. And now we're going to go ahead and integrate. So the antiderivative of dy is really just y. The antiderivative of e to the x is e to the x. And then we have minus 2x cubed plus c. Now on this one, we were given an initial value. We were told that it passes through the point 1, 0. So that is our x and our y. So we're going to go ahead and take the y value of 0 and plug it in here. And then it's e to the 1 minus 2 times 1 to the third plus c. So we get 0 is equal to e minus 2 plus c. And then we can subtract the e and add the 2, so we actually end up getting that c is equal to 2 minus e. And so what we are going to do, sorry that was a little crooked there, what we are going to do now is take that and plug that c value into the general solution that we found. So now it's going to be y equals e to the x minus 2x to the third plus 2 minus e. And that should end up being our particular solution. I always like to check a couple of things here. So first of all, I'm going to take this 0.10 and I'm going to plug it in and make sure that it still works. So e to the 1 minus 2 plus 2 and then minus e. So that does in fact give me a y value of 0. So I know that my initial point is still good. The other thing that I like to do is I like to, when I can, quickly check the derivative. So if this is my initial function and I want to take the derivative, I know that the derivative of e to the x is just e to the x, so I'm good there. The derivative of negative 2x cubed, so I drop the 3, that becomes a negative 6, and subtract 1 from the exponent, so that's where the 2 comes from. And then the derivative of 2 is 0, the derivative of negative e is 0, so I get back to the original derivative that I was given, so I know that this is the right answer. Okay? Now taking a look at question 3. It looks a little bit more involved, right? So again, we need to get the dx over to the other side so that we can integrate. So dy is equal to the square root of tangent x times secant squared x dx. Now, some of you have gotten really good at u substitution. Some of you are okay at looking at this and maybe seeing what's going to happen here. But just in case, I'm going to walk through the u substitution portion of it. So we can see here that the tangent of x is inside the radical. So we're going to use u substitution, and we're going to say that u is equal to the tangent of x. So if we were to take the derivative, we would get that du dx is equal to secant squared x. And so if we solve for dx, dx is equal to du over secant squared x. And so now we're going to go ahead and do the actual substitution part. So we have dy is equal to the square root of u times secant squared x, and then we're going to put in the du over secant squared x. And so now we get to the point where, oh, you know what I forgot though, guys? We can't do u substitution if we're not taking an integral. I forgot to write in the integrals here. I'm so sorry about that. So go back up here, do me a favor, and write in those integral symbols. We can't do u substitution for antiderivatives if we're not taking an antiderivative, so that is my bad. Please add those integral symbols, and then we need them here as well. Okay, so now we can take a look at it, and we can see then that the secant squareds cancel each other, and so we're left with the integral of dy equals the integral of, I'm going to change the square root of u to be u to the 1/2 du. And now this is just a much easier antiderivative for us to do. So we get y equals, I'm going to add 1 to my exponent, so that becomes 3/2, and that means this is going to be a 2/3, and then I need a plus c. Now the last step of doing this is we have to make sure that we get our answer back in terms of what the original one was. So we can't have the u in our answer here, which means the final step is going to be changing that u back to a tangent of x. So it's going to be y equals 2/3 tangent of x raised to the 3/2 and then plus c. That is going to be our final answer right there. Okay, let's go ahead and we're going to do 2 more examples for you guys to kind of look at, because I know that this is a lot. So we're going to look at these 2 examples, which are a little bit more complicated, and they're more like the quick example that I did in class today, where we do have to actually separate our variables. So let's go ahead and start with the first one. So dy over dx is equal to 3xy. So we can see that our derivative is in terms of x and y. So we need to get all of the y's and the dy's on one side, and then x's and dx's on the other. So it's easy enough to multiply both sides by dx, but then we also have to look at this and recognize that we have to divide both sides by y. So we end up getting dy over y is equal to 3x dx. All right, so again, multiply both sides by dx, that's easy, and then we had to divide both sides by y. Now I can go ahead and do the integral on both sides. So this is where we have to be careful now. We know that the antiderivative of 1 over y is the natural log of the absolute value of y. All right, be careful with that one, because remember this is 1 over y. And then equals, let's see, we're going to add 1 to the exponent, so that becomes x squared. So I need a 3/2 in front, and then I'm going to need a plus c. But now the thing is this didn't say just to take the antiderivative. It said to solve the following differential equation, which means I need to solve for y, and we haven't done that yet. So this is what we kind of talked a little bit about in class today. But we need to remember that if we have a natural log, to undo it, we have to turn it into an exponential. And the base on a natural log is e, which means I'm going to take an e and make that the base, and make both sides my new exponents. So this is really now e to the natural log of the absolute value of y, and that's going to equal e to the 3/2 x squared plus c. Okay? Now, we know that e to the natural log of the absolute value of y really just becomes the absolute value of y, and that's going to equal e to the 3/2 x squared plus c. Now, as a quick reminder, I'm going to go up here and I'm going to remind you that if we have x to the a times x to the b, that means we're going to add the exponents. All right, multiplying two things of the same base, we add the exponents. If we look here, we have 3/2 x squared plus c as an exponent, which means I can rewrite this as the absolute value of y equals e to the 3/2 x squared times e to the c. Now remember, c is a constant and e is a number. So if we have e, which is just a number, right, 2.7 raised to some power, that's just a constant. Okay, so we're going to keep going now, and this is now the absolute value of y is equal to, I'm just going to turn that into another c. It's just a constant. Now sometimes people might write this as like c1. I usually don't. I just leave it as c, but just in case you happen to see that, it just means that it's a constant and it's different than this one. Okay, and then we have e to the 3/2 x squared. Now the very last step for this one is y is still not by itself. We need to get rid of those absolute values. So if I need to get rid of the absolute value signs, then that means this needs to be a plus or minus. So it's going to be y equals plus or minus c times e to the 3/2 x squared. And that's going to be our final answer for this one. So there was a lot going on here, all right? We had to use e to get rid of the natural log. We had to use some powers of exponents. We had to recognize that e to the c is just a constant. So we can definitely talk about this in class tomorrow and go over anything on here that we really need to. All right, let's go ahead and do one more quick example. I know this video is getting a little long. So we're going to separate our variables first, which means get the dx on the right side, and we're going to divide both sides by y squared. So we have dy over y squared is equal to x squared dx, and we're going to integrate both sides. Now be careful here because we know that y squared is really y to the negative second power. So if I want to take the antiderivative of that, I know that it's negative 1 over y equals the antiderivative of x squared is x cubed over 3 plus c. You can write this as 1/3 x cubed also, but just to make it a little bit easier, I'm going to make it x cubed over 3 for now. So from here, we have to notice that we were given a particular solution, or a particular point, excuse me, for this one. So we need to take that and plug it in. So we have negative 1 over 1 equals 1 cubed over 3 plus c. So that's negative 1 equals 1/3 plus c. And if I subtract 1/3 from both sides, I get negative 4/3 is equal to c. So I'm going to take that and plug it back into my equation that I've got going over here. So negative 1 over y is equal to x cubed over 3, and then minus 4 over 3. I'm going to go ahead and write that as one fraction. So negative 1 over y equals x cubed minus 4 all over 3. And then solving this, you kind of got a couple different options for doing it, but I'm going to multiply both sides by negative 1. So 1 over y is equal to 4 minus x cubed over 3. And then I just need to take the reciprocal of both sides in order to get the y on top. So it's going to be y equals 3 over 4 minus x cubed. There's a couple of different ways you can get to that. How you solve for y doesn't really necessarily matter as long as we get to the same answer. So we can talk about that in class if we need to also. All right, I know that was a lot, but hopefully it made sense and you followed along okay. Make sure you come in and see me if you have any questions. I'll see you guys later. Bye.